Hello all. So in this video, I am going to explain what is the difference between A and address of A, where A is any array. So what I mean is if I declare any array A, let's say of size 5, containing some values, and then when I say A, what does it represents, and then what does address of A represents, okay? So this we have seen previously. This represents the base address, right? Base address. What do I mean by base address? It's the address of the first element, from where the array starts. Okay, so just drawing the block diagrams. Let's see. So this is my array. Then let's say the first address is 1000. Then this would be 1004, 1008, 1012, 1016. So 1, 2, 3, 4, 5. So A is a constant integer pointer pointing to this location, right? So, and that is why we can store A by doing something like this, right? But notice that the entire array is present at this 1000 address, right? Not just one element, but the pointer, this pointer just represent one integer pointer, right? The type is an integer pointer, so it just points to an int. There is no information that an array is present. The type information is actually not representing everything about the data, the type of data that is present there, right? The array information is not represented here. What I mean by that is that if I say P1, if I look at the type of P1, I would just see that it's an integer pointer, so there would be it would be pointing to an integer value. But I don't know if there are like further integer values. I mean, it's a part of array or it's just a separate single integer value. So what do I like? How can I extract that information if I want to represent? If I want to create a pointer of type array, which represents a type of array, how can I do that? So to do that, we have to use ampersand a to take the address. Okay, address of a. And now what would be the type of pointer? So pointer has to be of type integer array, right? Because now I know that the entire array is present there. I want to represent the type as that entire array is present there. So how can I write that kind of pointer? Okay, so I would write it like this: star p2 and then int and then this subscript. How to read this? Okay, how to read this? So I'll start with the pointer name, and I would say p2 is a pointer. Whenever I encounter a star, I would say pointer. So p2 is a pointer to an array of type int. Okay, so that's how you read it. You start by the variable name, and every time you encounter an asterisk, you would say it's a pointer, and every time you encounter a bracket notation, you would say it's an array. So I will write it down. P2 is a pointer. P2 is a pointer of type int array, right? And that is what is represented by address of a. Let's see this in a short program. So here I have written this program, right? So I've created this array, and P1 is my pointer, which is kind of taking the base address, just representing that it's an integer. The A just represents that it's a base address of the array, okay, which we just learned. So I'm not going to write it here. P2 is of type integer array, is a pointer of type integer array, right? And why do we need that? We need that because we want to store that type information in the array. Okay, and how to extract that from A? We say ampersand A. Ampersand A means that we want to say that, okay, we don't want like just the base address, but we want the address to be treated as an array, as the address of an array. Okay, so that's how we do it. Now I have written two print statements, value at P1, that is this one, and then value at P2. Okay, so let's try to run this and see what happens. Okay, all right. So as you can see, value at P1 is some address ending in 460, and value at P2. Essentially, like these two are same addresses, right? And that was expected, but the type is different. So both P1 and P2 represent the same thing, but the type is different. And we can also print one more thing, like what would be the size of P1 and what would be the size of P2. So because the type is different, P1 is of type integer pointer, so its size should be 4 bytes. P2 is also a pointer, but its type is integer array. Okay, so let's see what happens here. Printf, and I'm going to print the size of P1 and %d, and let's do a new line here. Size of is the, we get the size by using the size of operator, so you might be knowing. And then P1. Okay, and then let's copy this one and let's try to print the size of P2. Okay, save this. Let's try to compile this. Okay, so this one is expecting unsigned long. This is a warning, but that's fine for our case. So we'll just run this one. Okay, so size of both P1 and P2 are 8, and 8 on this machine, the size of pointer is 8. So that's why this is giving me 8. Now, can I do something like this? Okay, will this change the size of thing? And can I do this? Let's try to see. So that's fine, that's compiled fine. So no difference. Okay, P2 is also again just the size of the integer pointer. P2 is also of size. So when we are trying to print the size, we saw that both of them are of equal size, which is fine because both of them are like pointer variables, right? But if there is a difference in the type of both of those, which we were able to capture, so using the pointer arithmetic, now they should be, when we increment P1 and when we increment P2, they should give me different values, right? Because the pointer arithmetic works based on the type of the value that the pointer contains, right? Or the pointer points to, right? So let's see. So what I'm going to do is I'm going to increment. So I would just say P1 plus 1 equals %d, and I'm going to do P1 plus 1. Okay, and you'll see what this prints. And then I'm going to copy this one and see what P2 plus 1 prints. Okay, so let's see. And for the sake of clarity, I'm going to comment out these two because we know that these two points to the same location. Okay, so let's try this out. Compilation, all the warnings because of the format mismatch, which should be fine for our use case, right? So okay, let's try to run it now. Oh, but for P, okay, let me see. We need to see this value as well, right? Let me remove this, and let's print this one as an unsigned integer. This one also is unsigned. And here also let's use the unsigned part. Okay. And let's comment this one out because we know both of them are pointers, so both of them would be of size 4. So let's fine, this is fine, and let's try to run it now. So as you can see, this is the value P1 contained, and when we did p1 plus 1, this is what it prints. So you see, like, the value just got incremented by 4 bytes, which is expected because p1 is integer pointer. But p2 is a pointer which represents a array of size 5, right? So array of 5 size 5 uh, would be of 20 bytes, right? So if I do p2 plus 1, it should ideally be incremented by 20 bytes, right? So you can see this got incremented by 20 bytes. So that's what the difference of the type makes, and this will be handy when we would be dealing with 2D arrays. So thanks all for watching.